So yesterday we worked on solving or simplifying expressions, right? So we kind of went over the different properties and then how to combine like terms and whatnot. So we're kind of going to put that to use today when we solve equations. So I'll read through the definitions real fast and then I'll do some examples. So you don't really need to write them down. I mean, it's okay if you do, but I'm just going to go over them very quickly. So an equation is a mathematical statement that two expressions are equal. So the difference here is that they have that equal sign. So let me just pick a color. How about maybe orange? So an expression is a representation of at least two terms and one math operation. So that's what we were dealing with yesterday. So yesterday we had things like x plus 2. That's one expression. This is what we consider an expression. Or you can say y plus 3, z plus 4, even a divided by 1, right? Although that's just a, but these are all expressions. And so an equation is different from an expression in that we have two things with the equal sign separating them. So maybe we'll have 3 equals x plus 9. So the difference between these two is that this one has an equal sign, but this one doesn't. Oop. And so that's the main difference. And sometimes people will kind of mix these up when they talk about them. They'll call an equation an expression and an expression an equation, but they're technically two different things. Okay, so I'm going to go to some practice problems. And so the main point of these practice problems is to solve for the given letter or variable. So we're trying to do everything that we can in our power to get that letter by itself. And so we have addition. We can do solving by addition or adding. So our first example says 2 equals m minus 8. And so m is that letter that we are trying to get by itself. And so how do I do that? Well, the only possible way here is that we get rid of this 8, right? If I get rid of that 8, m will be by itself. But I can't just like cross it out, right? That's not possible. Because if I cross it out, this equation is no longer true. So 2 will no longer equal m minus 8. So what do we do instead? We have to, whatever we do to one side, we have to do to the other side. So whatever I do to one side of the equation, I have to do the same thing to the other side of the equation. So notice that we have a minus 8 over here. And so I'm going to get rid of that by adding 8 instead. Because negative 8 plus 8 just brings you back to 0, right? And so when you do that, you'll get m by itself. But I just said whatever you do to one side, you have to do to the other side. So because I subtracted 8 here, or I added 8 here on the right, that means I also have to do it to the left. So I also have to add 8 here. And so this is a very common thing that you'll see when solving equations. Whatever you do to one side, you have to do to the other side. So here, negative 8 plus 8 goes away. So that turns to 0, right? And this m, we just write it down here. So the m, nothing happens to it. So it's m plus 0. Technically, we don't even need to write the 0, right? So it's just m. What about the other side? 2 plus 8 is 10, right? So 10. So m equals 10. Maybe I should have written that in black, but whatever. So m equals 10. Or you can write here. Maybe make it a bit nicer looking. So m equals 10. And so we're going to do some more problems. And it's like that same trend. Whatever you do to one side, you have to do to the other side. So let's look at the next one. So here's the next one. N minus 1.2 equals 7.4. So here we're going to want to solve for n, right? because n is that letter, and we want to get the letter by itself. And how can I do that? Well, I can't just cross out 1.2, right? I have to add it to both sides. So this is like the horizontal line I'm drawing is kind of like an equal sign. So 7.4 plus 1.2 is going to be, well, the tenths place is going to be 4 plus 2 equals 6. Got my decimal point. And then 7 plus 1. Oh, why is it not syncing? Oh, okay, good. So 7 plus 1 equals 8. So this side is 8.6. And then this side, negative 1.2 plus 1.2. Well, because it's a negative plus a positive of the same thing, that just takes you back to 0, right? So this is just 0. And the n stays the same, so we just bump it down there. Oh, yes. There we go. So n plus 0 is 8.6. So that essentially just means n equals 8.6. And then I will box it. Yeah, so that's it. And so the next one is also kind of similar. Here we have 3.3 equals y minus 10.01. And so y here is our letter, right? And we want to get y by itself. And so how do we do that? Well, we don't want this 10.1 here. Oh, 10.01 here. So I'm going to add it to both sides, because whatever I do to one side of the equal sign, I have to do it to the other side of the equal sign, right? So this goes to 0, right? Because negative 10.01 plus positive 10.01 is just 0. And what about this side? 3.3 plus 10.01. Maybe I'll write it out here so it's a bit more clear what I'm doing. So 3.3 plus 10.01. So remember, the decimal points always have to be aligned when I'm adding the decimals. So technically there's a 0 here. So if I'm adding 0 plus 1, gives me 1. 3 plus 0 is 3, decimal point. And then 3 plus 0 is again 3. And then the 1 just goes down here. So 13.31. 13.31. I just wrote this thing out to the side so you can see it clear. So 13.1 equals y. The y just gets bumped down here. And the 0 just goes away. So it's going to be y equals 13.31. And that's going to be your answer. So it's simple enough. Okay. And so now let's do the same thing here, but let's do it with subtraction. So we're going to be subtracting stuff from both sides, because the last few examples was me adding stuff on both sides. So here's the first example. We have 0.2 equals r plus 0.9. So again, r is that letter we want to get rid of. Not that we want to get rid of, but it's the letter that we want to get by itself, right? Okay. And so to do that here, well, we have a 0.9 added to it. So in order to get rid of that 0.9, because I don't want it on the right side, I'm going to subtract it. So I'm going to subtract 0.9. And when I did that, whatever I did to the right side, I also have to do to the left side, right? So minus 0.9. And so this gives me 0. R just gets bumped down here, or that's not an equal sign, but it's a plus sign, r plus 0. And so what about the left? 0.2 minus 0.9 is going to be, I'm pretty sure it's negative 0.7. And so that's some decimal work with negative signs, which is kind of difficult. But overall, my answer is going to be r equals negative 0.7. All right. Okay. And so what about this next one? -6 equals k plus 4. So no decimals here, but we're going to do the same process. So we want to get k by itself, right? Oh my gosh. There we go. K by itself. So when we get k by itself, because the 4 is added to it, now I have to subtract 4, right? Subtract. So whatever I did to this side, I also have to do to the other side. So 4 minus 4 is 0. This k gets shifted down here. So if you did nothing to the letter, it just stays there. And then -6 minus 4 is going to give me -10, right? It becomes more negative if I add another negative number to it. So then this is going to give me k equals -10. Oop, maybe I'll write it bigger. Negative. Okay. Keep using different colors. Anyways. So that was addition and subtraction. So those are the most basic ones. Okay. So now we're going to try doing multiplication and division with these kinds of things. So multiplying and dividing. So first we'll do multiplying. There we go. Multiplying. And so our first example here is m divided by 4 equals 1.5. So m, I'll rewrite it because Microsoft doesn't let me do fractions. M divided by 4 equals 1.5. Well, I want to get m by itself, right? I want to get m by itself. So that means I want to get rid of the 4 at the bottom. But how do I get rid of the 4 at the bottom? To get rid of that number, I have to multiply the whole thing by 4, right? Because this basically is saying 1/4 times m. And so to get rid of that 1/4, I can multiply the whole thing by a 4th to make that a whole number, right? Because 4 times 1/4, these cancel, so that just gives me 1. So that'll give me m by itself, and that's why I'm going to multiply by 4. So I'm going to multiply this side by 4. And so whatever I do to one side, I have to do to the other side, right? And so I'll do the exact same thing to 1.5. So 1.5 times 4. So here, this 4 is going to go away. No more. So that just leaves me with m, right? There's no fraction anymore. M equals sign always stays the same. And then 1.5 times 4, I'll write it out here, times 4. So we multiply the ones place, right? So this is 20. So I'll put a 0 here. The 2 carries over. 1 times 4 is going to be 4, plus 2 is going to be 6. And this decimal has to stay because the decimal has to align. So this, since there was 1 decimal place here, there's going to be 1 decimal place in our answer. So it's going to be 6.0. So m is going to equal 6.0, or I'm just going to write 6 because they're the exact same thing. 6.0 and 6 are the same. So m equals 6. And so here we have another example. I'll write it out again. So -7 equals k divided by 6. So notice that k is in a fraction, and I want to get k by itself, right? I want to get k by itself. If I want to get k by itself, I don't want it in this fraction, right? It's kind of not what I'm looking for. I want it just to be k, not k over 6. So how do I fix it? Well, to get rid of this 6 in the denominator, I'm going to multiply it by a 6 in the numerator. And that way these two are going to cancel, right? And that just leaves me with k. So I'm going to multiply here by 6. And whatever I do to one side, I have to do to the other side. So I multiply this by 6, and I also multiply the left side by 6. So down here, I'm left with just k, right? Maybe I'll write it in black. I'll write it in black. I'm just left with k. And here, -7 times 6 is -42. Because if I multiply a negative number by a positive number, it stays a negative number. And that's going to be my answer. Or I can write, maybe I'll write it nicer. K equals -42. All right. So now let's do dividing. So dividing, I feel like dividing is a bit more straightforward than multiplying. So it's a bit easier. So dividing, here's my first example. So I have 8 equals -2 times W. So my ultimate goal here is what? To get W by itself, right? I always want the letter by itself. So in order to get W by itself, well, we have this 2 attached to it, right? That 2 is multiplied to it, not added, not subtracted, but it's multiplied to it, which is kind of annoying, right? We want to get rid of that in order to get W by itself. Since it's multiplying, we're just going to do the exact opposite of multiplying, which is to divide. So here I'm going to divide both sides by -2. So I'm going to do the division sign. Divided by -2, divided by -2. Usually I don't write the division symbol. I just write a huge line. And that tells me that I'm dividing both sides. But I'll do the division signs for now, just so it's more obvious. So -2 divided by -2, right, is 1, because any number divided by itself is going to be 1. So this is going to be W. Write it in black. This is going to be W, because we got rid of that -2. No more -2. But whatever I did to this side, oh my gosh, whatever I did to this side, I also have to do to this side, right? So if I do 8 divided by -2, well, 8 divided by 2 is 4. And that negative has to stay there because a positive number divided by a negative number has to stay negative. And so 8 divided by -2 is going to be -4. The equal sign stays the same, right? So W equals -4. Okay. And so for this one, so this one might be a bit more difficult actually. So let me rewrite it. 2/3 V equals 28. So I want to get V by itself, but there's this fraction right before it, and it's kind of bugging me, right? I want to get rid of that fraction. So how do I get rid of 2/3 and make it go to the other side instead? Well, I'm going to multiply it by its reciprocal. And so I'll write it over here. Reciprocal is basically 1 divided by whatever number you're looking for. So the reciprocal of 2/3 is going to be 1 divided by 2/3. And I'm not sure if you've done fraction division, but when you divide by 2/3, that means you're multiplying a number by the fraction that's flipped. So 3 divided by 2 rather than 2 divided by 3. So this is a reciprocal. And so here, if I want to get V by itself, I'm going to divide each side by 2/3. Divide each side by 2/3. So here, V equals, oh, I'm going to do black. So V equals, and then we have 28 divided by 2/3. So I'm going to write this out here. So 28 divided by 2/3. So the reason why I did this reciprocal thing is because this is just going to equal 28 times 3/2. So I'm always going to multiply by the reciprocal of the bottom. So 28 times 3/2. And so I'm going to simplify it before I actually do the math. So 2 and 28, these can cancel. 28 divided by 2 is going to be 14. And 14 times 3, show it off to the side here, it's going to be 1 carries over. It's going to be 42. So this is going to be 42. And that's going to be my answer. So that was probably the most difficult one out of all of these, actually. So what I did was I divided both sides by 2/3. And in the process of doing that, that means that I'm going to, instead of 28 being divided by 2/3, I changed it so it's 28 times 3/2. It means the exact same thing. And then I simplify because I can cancel out this numerator and this denominator. And so that gives me 14. And then times 3 equals 42. Okay. So then some more problems. So there's 3 here that are kind of going to be a combination of all the stuff that we did. So addition, subtraction, multiplication, and division. So let's do the first one. So 4x plus 2 minus 9x equals 13. So here it looks like I want to get x by itself, right? Because x is the letter that we have here. So first, I'm going to combine like terms. So kind of like what we did yesterday. I'm going to say, oh, I see a 4x and I see a 9x. And I can kind of combine those, right? So x stays the same, but the coefficients in front, I can subtract those two. So it'll be 4 minus 9, and that's going to give me negative 5x. 2 stays the same, so I'm just copying it down, equals 13. And so if I want to get x by itself first, I'm going to try to first subtract 2 here and subtract 2 on the other side as well. Because remember, whatever we do to one side, we have to do to the other side. And I don't touch the negative 5x. So this just gets scooted down. Negative 5x equals. So negative 2 plus 2 is going to be 0. So this part goes away. And 13 minus 2 is going to be 11. So negative 5x equals 11. So we're not done yet, right? Because we didn't get x by itself. And so here, negative 5x equals 11. I'm going to actually divide both sides by negative 5 because I want that negative 5 attached to the front of the x to go away. So here I'm going to say x, because these 5's cancel, equals negative 11 divided by 5. Let me rewrite it. X equals negative 11 divided by 5. And so you can leave it like this, like an improper fraction. Usually, eventually, teachers don't really care if you use improper fractions. At first, they might tell you to convert to mixed numbers, so like 2 and 1/5 or something. But as far as I know, eventually it does not matter whether you use improper fractions or not, where the numerator is greater than the denominator. Okay, so the second problem. So q divided by 7. I'm going to rewrite this so it's prettier. It looks like an A. No. Q, my Q's look weird, divided by 7 minus 1/7 equals 3/7. So this is a very strange one with all fractions, right? But it's pretty much the same rules apply. So I'm going to say, well, what do I want to get by itself? It's going to be Q, right? That's the only letter here, so I want Q by itself. So first, I'm going to add 1/7 to both sides. Add 1/7 to both sides. Because then that'll get me q over 7, right? This just moves down. Q over 7 is going to equal, so 3 over 7 plus 1 over 7. The denominators are the same, so I can just add up the numerators, 3 and 1. So that's going to be 4, and the denominator stays as 7. So here, now we have q over 7 equals 4 over 7. And so I don't want the 7 down here, right? Because I want q by itself, and it's not there yet. So to get rid of that 7, I'm going to multiply on both sides. So multiply both sides by 7, right? And the reason I do that is because 7 was in the denominator down here. So it was divided, q divided by 7. So if I want to get rid of it, I have to multiply back by 7. So q over 7 times 7 is going to be q, right? Equals, and then 4 over 7 times 7. These are going to cancel. So this just gives me 4. Oops. Use this color, 4. So fractions are kind of pesky, but that's how you would deal with them. And so usually you'll see if I have a number multiplied or divided in front of the letter. So like 5 here, and then 1/7 here. Typically what I'm going to do is I'm going to do my multiplication and division steps after addition and subtraction. So maybe I'll make a note. Oops. So note, it's easier to do addition or let's say and subtraction before multiplication and division. And so you can do multiplication and division before, like you can do it first, but I don't recommend it most of the time because it'll probably make your problem even more difficult and you'll probably be sitting there for longer than you should doing these problems. So I recommend do the addition and subtraction steps first, so like that, and then do the division and multiplication steps afterwards, just to make your life a little bit easier. And so let's see. I'll do this one. So the next example, 3x plus 15 minus 9 equals 2 times x plus 2. So it looks like a lot, right? So we kind of want to get this problem into something a bit easier on us because it looks pretty complicated right now. So I'm going to kind of clean it up a little bit by doing, by combining like terms and whatnot. So 3x, that stays the same, right? Plus 15 minus 9. So 15 minus 9 is going to be 6. So I'm going to write 6 instead. Equals 2 times x plus 2. So this is the distributive property that we were talking about yesterday. So this arrow drawn here and here. So this 2 is going to be multiplied to both the x and this 2. So it's going to give me 2x plus 4. And so now it looks a bit better, right? So I want to get x by itself. Well, I have x on both sides. So I'm going to try to get them all on one side. So I'm going to do this. I'm going to actually subtract 2x here. We'll do it in orange maybe. I'm going to subtract 2x here and subtract 2x here, right? Whatever you do to one side, you have to do to the other side. So that gives me x plus 6. Now I did nothing to the 6, so it stays there. Equals 4, because I did nothing to the 4 either. So x plus 6 equals 4. I'm going to write over here now. X plus 6 equals 4. So to get x by itself, now it's just a very simple problem. And to get x by itself, I'm going to subtract minus 6 on both sides. So positive 6 minus 6 give me 0. So it's x plus 0 basically equals, and then 4 minus 6. So 4 minus 6 is going to be negative 2. So that gives me x equals negative 2. Okay. And so I made this note here. You can check your answer by plugging your answer back into the equation. So if I really was unsure, like this is really helpful if you're like doing a test or something. If I'm really unsure if my answer was correct, like if I was unsure about maybe this one. Oh my gosh, messing up my arrows. If I was unsure about this one, I could plug q equals 4 back into this equation. So I would actually make q equals 4. And then I would simplify this expression. And if this side equals 3 divided by 7, then my answer would be right. So that's a really easy way to check whether or not you did the problem correctly. Anyways. So this is the last stuff. So turning words into expressions and vice versa. So here, we're basically just turning words into kind of the expressions that you saw in the last few examples. So 9, so let's look at the first example. 9 less than a number is equal to 13. So it says 9 less than. When we see a number, we're going to make this equal x, or whatever letter you want, doesn't really matter. But I'm going to let it equal x. So 9 less than a number. So 9 fewer than a number. So we have a number, but it's smaller. So we have to do minus 9, right? 9 less than a number. And is equal to, so we have the equal sign, 13. And so that's going to be my equation. And so I could then solve the equation, right? By adding 9 to both sides. And then I get my answer. So I'm going to box this actually. Oh, or I'll rewrite it. And this is what it's going to look like. X minus 9 equals 13. And let's look at the next one. So that's kind of similar actually. So 2 less than a number is negative 54. So we're seeing that number, a number is x, or any letter that you want, like P, A, B, C. But 2 less than a number is negative 54. So if it's 2 less than a number, we are taking away 2 from that number, right? So x minus 2 equals, so is the equal sign, negative 54. And I could go ahead and solve that equation. I'm not going to, just because. X minus 2 equals negative 54. Okay. So that's how you would translate words into expressions or equations. So if I said something like, if I had something like 4 greater than, rather than less than this time, greater than a number is 10, something, I'm making something up, but 4 greater than a number is 10. That means our number, x, has a 4 added to it, right? Because it's 4 greater than. Oh my gosh. Okay, not a triangle. Equals 10. And so that would be my answer if I was given this problem. So if it's less than, you're going to be subtracting that number. If it's greater than, you're going to be adding that number. And then multiply, divide, they are all basically what they sound like. So those are not that bad. So here are some, so we're going backwards now. So we're given, actually, this is not backwards, but we're given some word problems, and then we're being asked to find the equation and solve the problem. So let's look at the first one. So Lewis deposited $415 into his bank account. Let me scroll down a little bit. He now has $2,834. Write and solve an equation to find how much was in his account before the deposit. So before the deposit, let's let this amount equal D. Just making up a letter. So it can be any letter, but D. So D was the amount of money he had before he put in $415, right? So that must mean that his amount before the deposit plus $415 is going to be the amount he has now, right? 2,834. So I'm going to say this. This is going to be my expression or equation. See, I always mix those terms up. So D plus $415 equals 2,834. There. And so how do we know it's a plus and not a minus sign, right? How do we know it's one but not the other? Well, if it was a minus sign, that would mean the opposite. That would mean that he initially had D amount of money, but then if it was a minus sign, he would have taken out $415, right? He would have taken out $415. So then that wouldn't be the same anymore. Here we're putting in money. Deposit means put in money. But if you put a minus sign, that would mean that you're taking away money, right? So that's the complete opposite. So here, that's how we kind of know that we're doing it right. So D plus 415 equals 2,834. And so you could always solve this by subtracting 415 on this side and subtracting 415 on this side in order to get D by itself. And you could use a calculator, or you could just do the actual math. I don't feel like I need to do the actual math, but should be around 2,400 something. About. Okay, so it's going to be about that amount. I'm just estimating because I'm not going to go through the whole thing. That's fine. So now let's look at our last and final example. Jennifer is saving money to buy a bike. The bike costs $300. That's a lot. She has $100 saved, and each week she adds $20 to her savings. So she's saving up money for it. How long will it take her to save enough money to buy the bike? So it looks like here, this $100 that she already had saved and the amount that she adds to her savings each week is going to add up to equal $300, right? Because this is the ultimate goal. Her ultimate goal is $300. So it looks like to me that's going to be like the $100 she has saved in the bank already. And then you're going to add, each week is $20. So if that's the case, then I would have to say $20 times, I'll let W be the amount of weeks. So W equals number of weeks equals 300. So 300 is her goal. That's what she's shooting for. And then $100 is what she started out with. $20 is how much she saves per week. And so if we multiply that by the number of weeks that she saves up, we can get the total amount that she saved, right? Equals 300. So this is her goal. And so that's how we would write this. And so I'm going to write it off to the side here again. I'm going to actually solve this. So here, I'll subtract 100 on both sides first. And the reason why I do that is because I want to get W by itself, right? By itself. I want to get W by itself. So I'm going to subtract 100 on both sides. That gives me 0 here. 20W, nothing changed there really, so that stays the same. Equals 300 minus 100 is going to be 200. So 20 times W equals 200. So because we have this number is multiplied to W, in order to get rid of it, we have to divide. So let's divide each side by 20. So these 20s are now going to cancel out, right? So this is going to be W equals 200 divided by 20 seems like it's going to be 10. So it's 20 times 10 equals 200. So this side is going to be 10. And so it's going to take your 10 weeks to save up for that bicycle. Okay. So that was it. So if you have any questions, you can always email me, and I will post the homework. Oh, I already have posted it, but I'll post these notes on there too, so you can reference it. Anyways, you can leave now. Thank you.